Welcome to 3DOptix Tutorials. Today we are going to review the detector options that are provided for analysis for our optical system. First, we need to create a new file. I've pre-populated this file so we can just move into the project. Okay, as with most functions in 3D optics, there are multiple ways to place a detector. The first way is to select the detector object from the outliner bar here. The only two options in the outliner bar are the user-defined light sources and the 3D optics transparent detectors. Now this object bar is a drag and drop selector, so we will click and hold the detector and drag it to where we want in our virtual breadboard. Okay, really quick, let's center the detector by clicking on it, and it'll pop up the right ribbon bar here. So we're going to put it at 100 millimeters down the positive z-axis. Note that the default coordinate system is the GCS, or the global coordinate system for all objects, and corresponds to the center of the breadboard. Okay, now the second way to add a detector is to click and select Add Detector. So we'll right click with the mouse and we can select Add Detector. This does the exact same thing as dragging and dropping a detector from the left object bar. Do note that wherever your mouse cursor is, when you right click and select Add Detector, the detector is going to be placed there. Okay, now before we go any farther, if we want to delete a detector, we've got a couple options. First thing we can do is select the detector and hit the delete button on our keyboard. Let's undo that. Second option is we can right click and select remove. We can also go to the outliner bar on the left, select the detector object, click remove as well. And lastly, we can select the detector and hit the delete button at the right ribbon bar here. Okay, now let's set our parameters for our detector. We will once again select the detector, and we're going to see that the right ribbon bar pops up again. From here, we can change the name of the detector. We can move or rotate the detector around our optical system. We can also at the bottom duplicate or again remove it, delete it. But let's go back and click on the camera icon where our parameters are. We can now see the options available for the detector, which are simply the physical size and the transparency. We're going to make this detector 10 millimeters by 10 millimeters half width, so it'll actually be a 20 by 20 millimeter detector, full width. And if we drag the transparency all the way to the left, the center here of the detector becomes completely transparent. And if we pull it all the way to the right, it will become completely opaque. And this is good for aiming rays so we can see exactly on the detector where the rays are falling. And conversely, if we make it invisible, we see just the frame and we'll be able to see the rays propagate through it without a problem. And with it being invisible, it makes it easier to capture views of the ray paths if there are multiple detectors internal to the optical system and not just the output. All right, so this sets up the basics of our detector for our optical system. Now let's go change some of the more important parameters we'll use during analysis. All right, so let's go up to the top ribbon bar on the left and select Analysis Portal here. And from here, we can select which light sources we want to use for our analysis features here. So we'll leave that for now. And then down here is our single detector we have in our optical system. All right, so let's see what we can change here. First, we have the analysis. So we have a couple options here. The first is a fast trace spot analysis with incoherent irradiance. We can use this for the setup and alignment portion of our optical system to quickly look at our light source output. The next three are slower but more accurate ray traces. Two for coherent and incoherent irradiance with spot analysis, and one for phase. We'll leave the specifics of the analysis portal for a later, more in-depth walkthrough. Okay, now if we have multiple light sources, we could individually select each one and set how many rays we want for the analysis. This is a nice feature as you don't have to go back and forth between screens to change this option. And then we have the number of pixels in X and Y for the actual detector. Now this is not the half width number, this is the full length of the detector. And the last option here is the display. This is just how the rays are colored on the detector. We can pick false color, grayscale, or spectral view. Now, spectral view will color the output depending on the ratio of the wavelengths that hit each pixel. Okay, so we've gone over some of the detector options in the analysis portal. Again, in a future video, we will go over some of these features in more depth. Okay, so I want to go back and show one of my favorite features about 3DOptix detectors, the ability to make any surface a detector. So let's click out of here. This is a great way to limit the number of detectors that we need to add individually in our optical system, and also for a quick analysis of the light source propagation for zoom systems and other similar systems. So now we're back in the 3D layout. We're going to right click and we're going to open the optics menu. We're going to go to the left and select lenses, and we're going to select the first lens in the list. This is just an example, so it doesn't matter what the lens is. So we'll leave everything as is just because I want to show this capability. So we have our lens here right in front of our detector. Now, if we go over to the outliner bar, we can see if we expand the lens, these surfaces and also the local coordinate system that we are working with. Well, let's right click on the front face. And when we do that, we can see we have a couple options here. The last one is add surface as a detecting surface. So we're going to go ahead and select that. Now, once we do, when we go back up to the analysis portal, we can see that we have another detector. And if we click on that detector, we see it is now the front surface of this lens. And as usual, we can change any of the analysis that we want for this detecting surface. Okay, so let's go back and actually add all surfaces of the lens as detecting surfaces. So we'll do the back and the frame. Let's go back up to the analysis portal. And as you can see, all the surfaces of that lens is now a detecting surface. The frame is a nice feature because if you're looking at stray light or possibly light that's missing the front and back face of the lens, it's easy to do with this feature. So this is just a really nice feature because if you have something specific in your system that you want to look at, you can make that surface a detecting surface and see what is happening to the light there. Or if you're worried about how your light source is propagating through your system, you can see how it's interacting with every optical surface there. All right, I hope this video helped you better understand detector options in 3D optics.